Today, I'm going to, very briefly, in the next 20 minutes or so, we're going to talk about Anoma, Ethereum's intent machine, what intent machines are, how we got to sort of having to think about intent machines, why they're a more useful abstraction than just thinking about transactions. And then I'll also go through a bunch of examples here and sort of some of the affordances that intent machines are going to give us. So let's start with a very basic thing, which is, what is a VM? And really, a VM, it's an instruction set. It has a program counter, has different layers of memory, and fundamentally, it runs programs sequentially. Over the years, we've sort of started with the Ethereum virtual machine as the first full-fledged virtual machine, but sort of over the years, we started developing. By the way, could I get the timer started? Thank you. Great, thank you. So over the years, we developed a bunch of these virtual machines, but fundamentally, they all follow the same logic of being a sequentially that they execute programs sequentially. I mean, some examples here are really like the Solana virtual machine or the Neo virtual machine, but predominantly, I think the virtual machine that's mostly in production is actually the Ethereum virtual machine, not only on Ethereum main chain, but also on most of the rollups, right? But for example, like some of these ZK VMs, not necessarily the ZK EVMs, but the ZK VMs, they're still fundamentally VMs. They're virtual machines that will generally follow this model. And these things are very good at transaction execution, right? Like when you have the fully fledged state transition, VMs are very good at going, OK, I have a fully fledged state transition, and I just want to update the underlying state of the system. Let me run this transaction. Yeah, so as an example here, the Ethereum virtual machine. So to contrast this, what is an intent machine? An intent machine really takes a batch of intents, computes possible valid state transitions, and selects one of them according to some criteria, and only then updates the state of the system. And here, really, the important distinction between a transaction and an intent is that an intent is a partial state transition. It is, I have A for B, but I do not have B for A. Right? Like when I go to a shop and I go, here's some USDC, I'd like some milk, I have a fully fledged state transition. I have a transaction because the other side of the trade is effectively the physical milk. And this is something that, as a result, payments can generally be immediately executed on-chain. Intents, on the other hand, are partial state transitions. They're the idea that I have A for B, but I don't yet know who has B for A. This may be one person, maybe 100 people. It may be 15 different hops away. It doesn't matter to me. I just have an intent. It's a partial state transition over which I need to discover with whom to coordinate in order to settle and satisfy this intent. And this is a very fundamentally different abstraction because an intent is not directly executable on a virtual machine, right? Because there's no valid state update afterwards. If I only have A for B, I can't update the global state because it will be imbalanced. Like, I'm spending some money, but I'm getting nothing in exchange. So intent machines don't exist. Specifically, generalized intent machines just yet don't exist. Sort of the first one here is the Anoma resource machine, which, again, it's not a account model. It's not a UTXO model. It's a resource model. It's a model that allows you to very efficiently express partial state transitions so that you can figure out which counterparties to coordinate with. So I would, in the beginning, like to take a minute or so to talk about that Anoma is an interface. It is not an intermediary, and this is very important to understand. And the differences here are really crucial, and I think lots of times at the moment, people confuse intermediaries for interfaces, and I think a lot of intermediaries try to pretend really, really hard that they are interfaces, whereas in reality they're not. So generally speaking, intermediary it's an actor on the network. And oftentimes they're valuable ones, right? Like, but they're fundamentally a party that you interact with. And they have the capability to sort of leverage their privileged position in the ecosystem to almost always introduce extra security assumptions, most of the time be able to extract extra rent, and most importantly, they add actually unnecessary latency and complexity. And this is because you're fundamentally going to a specific counterparty with which you're interacting with. Like, you have to send something, like with intermediary, you have to send something to a specific party. It's not you're just using some code. It's you're interacting with a specifically identifiable counterparty. And sort of when you think about this from a global latency perspective, no matter how fast this intermediary is, even if the intermediary is an actual decentralized blockchain somewhere in the world, I now have to interact with this system, which means in most cases I have to send my thing to some global consensus instance, to some controller instance that then comes to consensus over this. If we don't, with interfaces, like two of us in this room can decide to directly talk to each other, and we do not have to route via some global instance. Like going via intermediaries is always going to be slower than directly just using interfaces. One really good example here are bridges. In our ecosystem, most of the bridges currently are intermediaries. They are fundamentally new trust assumptions. If the bridge blows up, and I'm not saying that they necessarily blow up, that they will blow up, but if the bridge blows up, you have to consider this as part of your personal security model. This is not you just using a free interface. No, you're trusting a specific identifiable third party, whether this is a single 1/1 multisig or a completely decentralized system. But you're trusting an intermediary here. And here it actually doesn't matter whether it's a multisig bridge or actually a chain. In the real world, we have also a great example for this, which is fundamentally banks. And it's, in the real world, actually kind of really weird that in order to access the sort of global financial settlement layer, you must go via a bank. Like, why is there not the point that I can just directly interact with the settlement layer without having to route via some intermediary that I now have to trust with my money? I mean, there are historic ideas for why this is the case, but sort of like on a technical side, there is no reason why we need to go via these intermediaries. Interfaces, on the other hand, are just protocols, which translates or represents like one semantic, for example, ordering, compute, and storage semantics of an underlying machine. They're simply code. They're freely copied. If two of us in this room agree that we all want to use the same interface, we can. The best example in the world for this, in my opinion, is TCP/IP, because it very much shows the difference. If TCP/IP was an intermediary, we'd all have to talk via a single Oracle server in a basement in Virginia somewhere. But TCP/IP is an interface. It's a permissionless thing, where if two of us in this room agree, we can just have a local device connection over TCP/IP and exchange data this way. And there's no third party we have to interact with. And I want to make this very clear. Like the Anoma protocol, it's just code. It's freely copied. It's an interface for declarative intents and implements imperative ordering, compute, and storage semantics of an underlying machine. But if two of you in this room want to just agree on how you coordinate over an intent-centric system, you can just use Anoma. You do not have to go via any central intermediary. You don't have to go via any chain. You can just agree on this as an interface. Actually, in the real world, in the blockchain world, there's also another great example here, which is IBC. IBC, like two people, two chains can just decide to talk to each other. They do not have to route via a central intermediary. Yeah, so this is very important to me that everyone understands this. There's no Anoma chain to which you must send intents. You can just use the Anoma as the protocol, the interface, without going via any specific Anoma chain. You can use this on whatever settlement system that you care about. Yes, so really, when you use things in this ecosystem, please think whether you're using interface or intermediary, because it fundamentally changes the assumptions and sort of security concerns that you must have. So with this, let's come to Anoma. Anoma is a universal intent machine for Ethereum. And actually, yes, one to far now. So it's, I think everyone sort of started speaking about intents lately, and when some people then come up to me and go, well, aren't intents just limit orders? And yes, this is true. All limit orders are intents, but not all intents are limit orders. And really what I'm speaking about here in terms of intents are fully generalized. They are just code and some amount of state. They do not restrict what you can do. They're not just, like an intent in Anoma does not know what a price point is, what an asset is. It does not know what a specific counterparty is. It just knows I have some state in some Merkle tree somewhere, and I'm willing to exchange or trade it or move it to some other party, to some other. I'd like to update the state. The nice thing is that as a result, intents don't have to always get posted on chain. Intents can be free. Like if 2 of us or 15 of us in this room want to locally do something using intents, we can just update our intents every half a second and just sort of submit this to our local network. And only if we actually find an intersection where, like, I have A for B, you have B for C, and the third guy has C for A, does this intent actually have to be settled on-chain, right? Like, we can have these very flexible systems where I can have incredibly quick and low latency updates all the time over whatever intent I care about, and only when there's an actual match does this get settled and executed on-chain. Yes, what does this mean for a number of parties here? So this fundamentally means that builders can write dApps in terms of intents instead of transactions or execution traces. And really here the distinction is that transactions are really, they are very imperative in the way they work. It's a transaction just defines some specific execution trace, and then you update this. So you start with a state, and then you say, I'd like to modify the state using this execution trace, and then I'm at some future state afterwards. And intent, on the other hand, is very declarative. An intent just says, I'm currently at state A, and I'd like to be at state B. Anyone that can make this happen can take this and settle this on chain. I do not have to describe the specific compute that needs to happen in order to get me from state A to B. I just describe what are the fundamental state changes. I have a declarative thing that I sign over that I'm currently in this state and I'd like to be in this other state. Can some solver in the network please figure this out, how to get me there? And again, here it doesn't matter whether there's one other counterparty or there's 100 other counterparties that have, as long as you have some way where all these intents balance in the end, once combined into a transaction, the system will accept them. And interesting enough, like rollups fundamentally are intent-based systems, intent-centric systems, right? Because when you think of what a rollup does, it has some user has an intent A to B, some other has B to C, the third guy has C to D. What a rollup does, it just collapses the intents, all these partial state transitions, into A to D, or if they actually, and then really the signature over from the rollup provider is sort of to finalize the thing that is C to A, or D to A in this case. So intents are pretty much all around us. We just don't yet have sort of coherent abstractions that try to have a unified approach towards intent-centric systems. Yeah, it's just a universal standard for intents and application formats. It does not constrain what kind of specific intents you can express or build. Again, if you want to represent Gitcoin with this, you can. If you want to make this about trading, you can. I mean, like, order book exchanges are great examples of a specific application using intents. But the system itself is not constrained to just order book exchanges. It's generalized intents. You can, whatever you can express in code, you can express in this intent framework. And maybe this is the most important point, which is intents and dApps written with Anoma can be ordered and solved and settled on Ethereum. This is, or anywhere else in the ecosystem. I mean, like, to a large extent, an intent-centric design like Anoma solves the consensus, actually implements shared sequencing. So if you're very much interested in generalized shared sequencing, look into Typhon, the consensus model here. But fundamentally, intents can be ordered, solved, and settled on Ethereum or on one of the other rollups in the ecosystem, right? Like, it can also say, like, my intent is either settleable on Arbitrum, Optimism, or Ethereum main chain, and then users can pick. Or maybe the users actually don't want to pick, and they just care, like, give me the fastest, cheapest thing, and then solvers can pick, well, it's fastest or cheapest to put this onto Optimism right now. But maybe for some things you don't want to do this. For some things you actually may care about the underlying security, where, like, I only want this settled on either Arbitrum or Ethereum main chain, right? And so with intents, users can incredibly flexibly express what kind of specific settlement guarantees or security models they actually care about. Yes. So, yes. Anoma is a universal intent machine for Ethereum. Intents and dApps written with Anoma can be ordered, solved, and settled on Ethereum, or anywhere in the ecosystem, right? Like, this could be on an EVM rollup, this could be on an Eigenlayer AVS, you name it. This could be on a ZK EVM rollup, on a ZK VM rollup, wherever you can build a protocol adapter or an Anoma protocol adapter in order to get access to the intent, to sort of the intent stack, you can use this to settle there. Yes. So why use Anoma to build dApps? What kind of affordances do you actually get here? Well, first, you get permissionless infrastructure. And this is not to say that there's just some magic cloud in the sky. It just means that there's no whitelist. Like, you don't have to ask someone specifically to run this code. As long as people in the ecosystem, node operators, for example, Ethereum validators, run this as a sidecar, you get access to intent-based infrastructure. The really cool thing, though, is you get intent level and intent machine level composability. And what does this actually mean? One of the big challenges in a transaction-centric world is that even though users have intents, they can't express this. And as a result, things don't compose really well. Like, I fundamentally have to choose whether I'm interacting with something like CowSwap or something like Uniswap. We're splitting this here. You, as a user, must choose at the interface level where you go. With intent level composability, you just define that, well, I want to do A for B, and maybe it goes to CowSwap, maybe it goes to Uniswap. As a user, you don't have to care. You get full intent level composability, and this is not just over, for example, like marketplaces, order book exchanges, or generally AMMs. This is across many different things. For example, a user may say, I want to trade A for B because, and another user then wants to go, well, I want to put B into Gitcoin. All of these things start composing with each other at an intent level because, again, they're just state updates. They're just declarative state updates. And rather than every user having to make the top-level choice on, like, I want to go to this specific thing and do that specific compute, I can say, well, I want to get this general state change, and then solvers can figure out what is the most optimal route in order to satisfy all of these things. And you get intent machine composability, which means that you can treat many different networks, many different rollups, for example, as a single intent machine. Even though under the hood, they're composed of many sort of separate intent machines. In the intent itself, you can describe whether you care about security model A or B or C. And really, I think this is going to be a fundamental unlock for the entire ecosystem, that all of a sudden you get this composability not just at the settlement layer, which is what really transactions give you. You get composability at the intent level, like at where you do counterparty discovery, so that users don't have to fundamentally pick which central server they're interacting with. They just pick, I want to get A for B. The rest of the system can figure out how to get me this. You also get information flow control. Information flow control really means currently we have systems that are fundamentally designed around a single large piece of global state in the middle somewhere, right? Like, this is like the global Ethereum state is a single large piece of state that lives in the middle and has to be synced and understood by everyone. Data or state is going to move to edge devices, specifically because nowadays we can have proofs over data on our edge device. So like in any reasonable system, not only from a scalability perspective, but also from a privacy perspective, you actually want to move more and more data away from the sort of fully public middle, thing in the middle, towards end-user devices. So that my phone here holds my state, and when I interact with the system, I then declare that I am willing to reveal this kind of state, and maybe I publish it fully transparently, or maybe I say, well, I have this state, and I'm willing to author a proof over the state. And this is what information flow control gives you. It makes what users reveal not a choice of a specific application, but rather a property of what the user chooses to do. And sort of the simplest example here is that maybe you have a case where some people want to trade transparently, and they sort of just attach a plain text signature to their state. So they reveal all the state that they have and who they are via plain text signature. But maybe some other users actually want to trade privately for whatever reason, and instead of attaching a plain text signature, they just attach a ZK proof. Those two things can still be composed into a single transaction and result in a single state update on-chain. So yeah, and regardless actually of the privacy implication with information flow control, it's also from a scalability perspective. Like having this large piece of global state is not super scalable if instead my individual state can live on my phone and everyone else's individual state can live on their phone. And you get heterogeneous trust, which I think really is something that's very underappreciated. But you want to have a model that has heterogeneous trust assumptions. Not everyone and their mother will want the same global security model. Like my parents, I don't think I will ever be able to convince them that something is super secure and decentralized. They will always trust the local government more. And this is sort of just a fundamental reality that different people have different trust assumptions. And to some people, they want to have the most globally decentralized system. But to other people, they actually trust the local 5 friends, and they want to have their financial system, their financial assets secured by their local 5 friends, right? And with intents, you get this heterogeneous trust model where users can define whether they care about global decentralization or they care about localized sovereign systems, right? And it just makes this very transparent in the architecture so that we don't have to go like, well, here's an enterprise blockchain that like does the thing for this local city, and here's this global thing, and moving between those two systems is very difficult. Rather, we can have one single unified intent architecture that goes, well, as a user at runtime, I pick which specific security model I want to care about right now, and I can always move between them freely, and my application can roam. This is actually the biggest thing, which is applications can roam trust models. Rather than redeploying the same application on every possible settlement layer, you deploy the application sort of at the intent level, and then users decide where this application fundamentally runs. Yes, so some novel ideas for dApps on Ethereum. If you're interested, they fundamentally will need intents. So if you like hacking around with things, take a look. I hope this is some inspiration. Public signal. This is effectively an inverse to Kickstarter. Rather than being a supply-side market where I sort of go, well, I'm willing to supply these kind of services. Do you want to give me money? We can have a demand-side market where many of us may say, well, I would like this kind of service, and only, for example, a simple example is we all want Starbucks coffee, and so if everyone chimes in $5, and if we get enough people together, maybe someone is willing to go, well, I know that this specific cryptographically signed market or demand exists. Let me put it out there. Do I have another 5 minutes, by the way? OK, great. Yes, then I'll quickly run through this. So this kind of marketplace can exist where people where then a supplier can go, well, I know there's demand. Let me satisfy the other side. Something that I deeply care about is sort of around nuclear research. Rather than sort of people building nuclear reactors, we can instead go, and then hoping that someone buys it, we can each go, well, I would like this specific thing. Let me signal this to the market that there's an actual interest here that I have. Scale-free money, actually, I think this is the end game for our entire industry. This is about the capability to say everyone locally issues their own monies. And my monies effectively represent my economic trust graph with my community. But by having this kind of scale-free money system, where I can very transparently exchange my money for someone else's money for someone else's money, we can build a very global financial system that represents local economic realities quite well. Multi-chat, it's effectively a privacy-preserving version of Slack. And a promise graph system, it's how can organizations structure themselves around the actual work not being done rather than a sort of like high-level design for what the organizational structure should look like. Yeah, if you like any of this, please scan the QR code. There's a bunch of ongoing discussions here for what kind of applications are possible in this new architecture. Perfect. And with this, I'll come to the quick TLDR, which is it's VMs and IAMs. It is not against or versus or IAMs. It is fundamentally intent machines are built on top of virtual machines. Intent machines do not replace any existing infrastructure. They are just another higher level of abstraction to make our lives easier while building an ecosystem. They are not, if we do not have virtual machines to actually run the settlement system, IAMs are all very nice thought experiments, but we cannot run them anywhere. Care about interfaces, not intermediaries. Many people will tell you that you should use their thing, and in reality, you should use the intermediary. I mean, if that's your thing, please go ahead, but like everyone should just be aware of are you using an interface or an intermediary. Yeah, what does the universal intent machine mean for Ethereum? Well, we get intent-centric dApps, we get a bunch of standards for intents, and we get the capability to settle everything on Ethereum. I went through the affordances that Anoma actually built, from permissionless infrastructure to intent-level composability, a bunch of things around information flow control, as well as heterogeneous trust assumptions. Yeah, and then lately, if you want to chat about more novel ideas of what we can build in this new architecture, find me afterwards. So yeah, what do you think? Please feel free to scan the QR code. Chris, my co-founder, wrote a very long blog post on ETH research, and or a very long post on ETH research. Some of you may have read it. If you want to read it, take like 2 hours, probably, maybe more. It's a very good post, though, and it provides a much more comprehensive overview with sort of backlinks to all the underlying research that goes into Typhon, the consensus, the intent machine abstractions, the Anoma resource machine. So yeah, thank you very much.
All right. Please give it up for Adrian Brink. Very nice talk about the beauty and a nice example of the beauty of composability and modularity.